All right, it's 2:40. Hello, everybody. I am Clint. I work for a company called NetFoundry. We are the sponsor and main contributor to an open source project called OpenZiti. Thanks for having me at the One Summit. I enjoy the Linux Foundation events. As every good open source project requires, we have a mascot. This is Ziggy. So if you're interested in Ziggy, you can check him out on Twitter. We'll see him later. He also shows up throughout the presentation. So usually when I give this presentation, this is one of my favorite slides because most people are like, zero trust. It's such a misnomer in general. And this is what people's eyes usually do. They just glaze over and like, whatever, zero trust is baloney. So this is the first conference I have ever been at when other people have actually talked about zero trust ahead of me. It's amazing. So we're going to learn a little bit about zero trust. So if you guys are all pros, you can just glaze out like Liz Lemon is here. Anybody know what this might be? Anybody? Anybody? That's right. This is the longest path a human can walk across the globe. So this is your zero trust journey, because zero trust is not a, hey, I'm just going to do zero trust and now it's done, right? It is absolutely a journey. I've heard other people say this exact phrase already during the conference, and it definitely is. I love this slide because you can start at which end, I don't care which end you start at, but getting to application embedded zero trust is a real journey. So we're going to look a little bit about current network security setup, probably all background for everybody, so feel free to sleep, but if anybody hasn't done that, you'll maybe learn something. A couple of zero trust pillars we'll look at. We'll see some OpenZiti superpowers that you get by adopting the Zero Trust SDK into your application. And then we'll learn about some of those superpowers, maybe in whatever order I put them on the slide deck here. So current network security setup, castle and moat. I saw Javier talk about that earlier. Here's a basic network. You know, we got a corporate office in the lower left. We got some IoT devices with wireless transmitters. We got my house where my laptop and my kid plays his video games. Generally speaking, we have this castle and moat mentality, right? So every single little network is its own little fiefdom. Once you've made it across the drawbridge, once you have made it through those walls, you are considered safe and secure. Nothing can go wrong. I love the quote that says that a network is built to share data, not secure data. And that's what it's about, right? So back in the old days, back when I was doing my development work, this is how it was. HTTP, telnet, perfectly fine when you're on the perfect, you know, it's my home network, it's my enterprise network, I'm safe and secure. Well, that was probably a bad idea. So we said that was a bad idea, and we said, hey, let's use TLS everywhere instead. So that was a good idea, right? TLS, it's probably, it's all we need. This talk is over, we can be done now. But of course, TLS is not enough either. So TLS was such a good idea that there were a couple of projects that came out. One by the, I don't have my notes, Electronic Freedom Foundation, I think, made HTTPS everywhere, and then another one called Let's Encrypt, which probably everybody here has heard of. You may not have heard of HTTPS everywhere, but you almost certainly have the results of that every day in your browser right now. So back in the day, back in those dark ages with non-TLS protocols, we would send HTTP over the clear. HTTPS everywhere said, hey, that's a really bad idea. Why don't we look first, see if there is an HTTPS endpoint, a secure endpoint, and we'll just slide you on over. It was so successful that the Electronic Freedom Foundation, whatever, Frontier Freedom, yeah. They are discontinuing HTTPS everywhere because every major browser just does this now, as probably should have been from the beginning. Let's Encrypt, free, making it easy for people to find their own certificates, making it free for people to have TLS. Two important projects. So why are we so interested in TLS? Because an attacker, we have a nefarious attacker now. They have plugged into the network, and what are they going to do? They're going to do what attackers do. They're going to go find some target of opportunity, and they're going to move to it, and they're going to compromise that target of opportunity. It's called horizontal movement. In case everybody's not aware, this is how your VPN works right now, right? Once you're on the VPN, you almost certainly have access to, I mean, I don't know, I've never worked at a really refined company who has a really refined VPN policy, but usually it's I access everything once I'm on the VPN, and behind those walls, I'm safe. So First thing we said is, hey, let's do this thing called segmentation. So here's Ziggy again. He's got his cop outfit on. Why would we want segmentation? Well, we want segmentation because if that nefarious actor tries sending data to that target of opportunity, Ziggy's in the way and says, no, sir, you cannot pass. We'll stop your traffic. But attackers are relentless, right? What are they going to do? They're going to find that laptop that needs access to both of those machines. If it's your QA developer, it's your actual developer, it's your ops agent, then they're going to compromise that machine, move right on to the target of opportunity, and just keep on their way. They are relentless. They will not give up until they find whatever they're trying to look for. So let's talk about how zero trust and some zero trust pillars can actually help attack that. We're going to go back to the basic network. This time, we're going to introduce this concept of a device identity, or just identity. So an identity is a cryptographically verifiable, strong identity. So now the network doesn't even allow you onto the network unless you have one of these strong identities. So that's great. Getting that identity is difficult. So here's one way to do it. You might have seen Javier talking about how to do it with blockchain, which is pretty cool. But this is the way the OpenZiti project does it right now. We can talk about that later if anybody's interested. It's 9 steps. It is kind of complex, but we can talk about that if anybody's interested. Really great blog post written by Andrew Martinez down here. It's a 5-step about how we bootstrap that trust. All these slides are on the Sketch app too if you want to download them. Zero trust device identity. So now we have that nefarious person. They have plugged into our laptop or our network, or maybe they've joined the Wi-Fi, however they've done it. But our overlay network is smart. It understands that this user does not have that strong identity, cannot send those packets. Great. So what happens? Well, they find one of those users who can access the network, who has the right identity, compromise that one, maybe dropping USB keys all over a conference like this. And now they're going to find wherever they're going for, whatever that target of opportunity is. So that's where least privilege comes in. Least privilege says, all right, now the overlay network understands who is trying to connect to who. So now when that nefarious attacker comes in, tries to get over to that target of opportunity, what's going to happen? Nothing, right? The network stops that. So now we have the second pillar of zero trust, least privilege added. Well, what happens if they contribute or they actually get somebody who has access to that machine, right? You're kind of toast on that one too. So this is not a panacea. We're about making it more difficult for an attacker to get at what they're trying to get to. We're trying to make it so expensive that they'll just move along and attack somebody else. Right? We don't care if they attack us. We just don't want them to attack us. Attack anybody else. So now we have posture checks. This is a continuous authorization as well. A good zero trust overlay network will do something like this, continually verifying that you have the right rev of software, continually verifying, well, not continually, but you're on the right operating system. Maybe only the Mac people can access the HR website for whatever reason. And that's great because if you fail the posture check, same idea, right? You can't get that traffic to follow through. All right, application embedded zero trust. What does that mean? Well, let's go back and talk about an overlay network. I've already mentioned that term. I wanted to make sure everybody knows what we're talking about when we talk about the ZT overlay network. So ZT overlay network, or any overlay, is going to be composed of a controller. The controller's job in life is to make decisions, right? You are allowed on, you are authorized, that sort of stuff. And then there are these things we call routers. Routers are nothing more than what they sound like, routers. Their job is to send data to other routers and figure out how to get your payload from one point to the other point as fast as possible. These things all form a mesh overlay too. So if you want to, you can configure them in a full mesh pattern. And that's all mutual TLS. Again, zero trust. Everything has to be explicitly trusted, not implicitly trusted. So mutual TLS. And that's for one purpose, to connect edge endpoints, the API, or your machine, your computer, to do one thing, which is send that data, hopefully, ideally, securely. Here are 3 levels of zero trust. What's important about this slide is you can mix and you can match either of these 3 levels. If you have zero trust network access on the top, you can have on your left-hand side, you can marry that with zero trust application access on the right-hand side. This is not 1, 2, 3. This is 3 factorial, 6 choices, right? And you can choose how you want to mix and match them. What is zero trust network access? Well, like it showed you before, basically you are trusting your whole local network. This is what lots of vendors will tell you is zero trust. And it's pretty good, right? You've got a nice zero trust connection in between your trusted zone, but you still have a trusted zone. So the next greater expansion of zero trust, the next logical expansion, is you bring that zero trust all the way to your host. Lots of good open source projects do this right now. You've probably heard of WireGuard. WireGuard's one of those good ones. OpenZiti is another great one, right? So you can put an agent, basically you install an agent on each machine. That machine now has zero trust baked onto the machine. But wait, there's more. We can go one step further, of course. We can go all the way into the application embedded zero trust. This is fantastic because now your application does not need to trust the host operating system as much, not entirely. You got a little bit of trust there. You still have to trust the file system. You still have to trust nobody's compromised your memory and can overwrite it and do nefarious things there. So there's a tiny bit of trust, but we're, again, expanding how much trust we actually have or how much lack of trust we have. That's still great, but we got one more step on top of that too, which is a hardware-rooted trust. So if you can stick some sort of FIDO type of thing in there and touch it, or some key that can unplug some hardware root of trust, you can now eliminate a whole bunch more trust from your device host or your server host. So that's all great, right? So now let's look at application embedded zero trust, and what does that mean? We'll take our little attacker, we'll take our target, we're gonna smush an SDK into a package, we're gonna put a little lock symbol on it, now it's secure, and then we're gonna deliver that to the attacker. Why is that great? Well, now if the SCP application sends SCP traffic, fine. SCQL can send SQL, FTP sends FTP traffic, but if SCP tries to send FTP traffic, it cannot do that. It has no notion how to actually even send packets to the FTP server. Same is true for all the other stuff. I'm gonna speed it up because I only got 30 minutes. Here's OpenZiti. All right, so there's that long path again, because you're gonna probably start with something called the tunneling application. And that tunneling application is how you would get to your zero trust host access. Now you might start at the router, so those routers can do zero trust network access. So that's another part of your journey. But there are all these things called tunnelers too. And the OpenZiti project provides these, all for the major operating systems, including mobile operating systems. I have one on my phone right now. The killer power of these tunneling apps is something that I like to call private DNS. It's also authenticated DNS. You can't get at these DNS names. Is that always redundant? These DNS records, that's better, unless you are on the zero trust overlay, which is an absolutely killer feature. If you turn the identity off, the lf.1 summit or fluffernutter or vault.ziti, you can no longer access. Now, that's really cool because they're also invalid top-level domains. If anybody doesn't know, top-level domains, there are only so many, .com, .org, whatever. .ziti doesn't exist. Oh, I updated that slide, but not that slide. Look at that. Anyway, authenticated private DNS is a killer feature of these tunneling apps. All right, let's talk about application embedded zero trust. Why is that amazing? Anybody recognize the thing on the top? This is the limousine that the United States president rolls around in. Has all of its security built into it, baked in. You don't know where to attack. You don't know that it has a bomb-proof door. You don't know that it has, I mean, you do because it's the beast, right? But you don't know that it has bulletproof windows. You don't know that those are run-flat tires. You don't know it has explosion protection on the, right? It's all baked in. You can't see it. You don't know where to attack. As opposed to Mad Max, right? You know right where to attack Mad Max. You know where all of his armor is. You know where the holes are. You know what gaps to go penetrate. This is the build it in versus bolt it on type of mentality. Another great superpower is addressability. I've been a developer for a long time. I didn't ask how many developers we have here. I'm afraid how to ask that question. But in the past, I always have to use a DNS name, and that DNS name will resolve to an IP address, right? And then when the when the payload is actually delivered to my application, if I'm really, really lucky, it just sits on the open internet, and I can get at whoever's source IP that came from, and I know, oh, that's Tom coming in, or it's Bob or whatever. But as soon as you go to an enterprise, you lose all of that, right? You have no idea where they're coming from because everybody comes from Microsoft's external IP address. I'm sure everybody realizes that. But with a zero trust overlay, you know that Clint is sending traffic to Prometheus because there's a strong identity. It's communicated during the exchange. When Clint is trying to contact Prometheus, you know it. That's really cool. As a developer, that's awesome too because I don't have to fool around with IP addresses. It's not just for the client. We always think about the client. Let's secure the client. The VPC is safe. Let's secure the client. But you can take an SDK and slap it into your server app too. And why that's awesome is because you'll no longer have listening ports. I love this Superpower so much. I put the slide up there twice because it's so cool, right? As a developer, I don't have to open holes in my firewall. I don't even have to talk to the firewall guy. So that's nice, right? Like sometimes that takes forever. All right, why is that important? Well, there is this thing called Java, and it has this vulnerability called log4shell. And if you haven't heard about it, my God, I don't think you have any servers on the internet. Because like last December, everybody's Christmas was ruined by this. And so you got a nefarious attacker compromise log4j, and all of a sudden, your whole day's ruined. Well, if you had a zero trust overlay network, you wouldn't be able to even access those protected log4j resources. Those of you who are astute will say, but Clint, I'll just go compromise one of those. And you're right, you can't fix that, right? So what you can do is you can just shrink who's going to attack you from everybody to just the people that you know and trust. Oh yeah, let's not forget about Spring. Spring had one of those too, CVE, a critical vulnerability and exploit, 9.8. Somebody, I don't know who it was, 8.5, said 8.5, and I don't know, one of the presentations said, oh, maybe don't deploy anything less than 8.5. That's a good idea, right? 9.8, terrible. That was you? Yeah, nice. It's also great as a developer. You can talk from the server to the client, which is really cool. If you've done any IoT stuff, you know this is a big deal, right? Like getting data down to the edge is a pain in the butt. So being able to address the edge directly by strong identity, really cool. It's also, because it's an SDK, can be serverless as well. So I had an intern last summer. He took our Python SDK. He used Lambda, and he used the Lambda to scrape the NIST database of CVEs so that we could find 8.5s and higher. Funny enough, that was the same number. And then I get sent a Mattermost message, which is a chat app that we have behind our Zero Trust network. I get sent a Mattermost message, and then Ziggy can tweet about interesting CVEs. I don't know if anybody here's from Cisco, but one of the ones, kind of talked about Cisco one day. All right, libsodium, really cool. This is baked into the CSDK. This is great because it uses this fancy thing, cha-cha-20, poly 1305. All that really means is it uses end-to-end encryption. It's on by default. You have to go out of your way to turn it off. Somebody else was talking about man in the middles, or sorry, people in the middle. I've been keeping to try to change that phrasing for a long time. People in the middle, because end-to-end encryption does not work with somebody who's inspecting your packets, right? Somebody wants to get their grubby mitts on your TLS packet, you just say no. So cha-cha-20 poly 13.5 works really well with low power devices. That's why libsodium is really cool. Port inference. Just put a port sniffer on any network, you'll know what's going on, right? Well, what if all of that traffic was over port 443? Well, now what do I do? Oh, good heavens. So with an open source overlay like OpenZiti, all your ports are port 443 or whichever port you choose, 10,000, whatever floats your boat. I recommend 80 or 443 because almost everybody lets that out. Not everybody, almost everybody. Ziggy's got his cop outfit on again, continual authorization. So we have some posture checks. You can check that the device is part of the domain and actually authenticated to it. You can check that the MAC address is correct. You can check that the operating system is correct, that it's running the proper process. Usually that's just like him running the right virus scanner. A self-healing mesh overlay, very important. You want your overlay network to be able to be self-healing. This is kind of like water. So easy, right? Everybody can probably read that in the back. Yeah. So there you go. I made it. No, let's make it a bit bigger because I know how these presentations go. In person, the first time I presented that slide live, what a debacle, because you couldn't see a thing. So anyway, this is the Java example. On the top, you can see as a developer, I had to know what my IP address is going to listen on, in this case, local address, and port 8080. I one time deployed an application thinking that it was listening on port 8443, only to find out that, on port 443, only to find out that load balancer guy thought it would be really smart if we took 443 and shoved it over to 8443. I can't even tell you how long it took us to figure out why my server wasn't receiving any traffic anymore. Well, with a zero trust overlay, you can just bind to the service and the identity, and the SDK takes care of the rest. My favorite superpower, implicit MFA. No longer do you have to have TUFA enabled. You have it implicitly enabled by just having that strong identity on your machine, whatever it is. If you add 2FA, which we support, great, now you got 3FA. You call it 3FA if you want, but that's just such a killer superpower. There are lots of times on Reddit, by the way, the zero trust slide comes from Reddit, because Reddit told me how stupid it was. But on Reddit, lots of people will ask about what happens if somebody gets your password? Well, one of the cool things, social attacks are much less attackable if you have TUFA, not implicit, enabled. I was at the Rochester Security Summit. I'm from Western New York. And at the Security Summit was an FBI agent. He said something like 60% of all attacks would have been stopped if they just had TUFA enabled. So implicit MFA, bam, you're stopping 60% of attacks right there. Demo! I saved time for demo, right? I don't know how exciting this will be for people, but hopefully it'll be exciting. What I've done is I've used our little Docker Compose Quick Start, and I've deployed a ZT network that looks like this. Now, it's a bunch of noise, really. Really, you just care about the ZT router here, and you care about this one right here, because there's this blue network. It's really hard when you run everything locally to prevent your own machine to access other things, but Docker's pretty good at it. So I have a Docker network where I've installed Vault instead of this web test server. So it looks like this. So I have a Vault client. It's able to access Vault over the secure overlay. And so I've already done that. I'm going to show you Vault. I'm not a Vault expert, but the reason why we used Vault here, I'm actually doing this for another project, 2 projects. One was a fun project with a guy from my local dev group. And then NetFoundry is actually looking to replace the communication. And one of the things they're looking to do is to use Vault to secure workloads, right? So the short-term certificates, Vault is great for that. Vault is already deployed in NetFoundry. They were like, hey, we love OpenZiti, but oh my goodness, it's so complicated. I said, no problem. I'll come in and I'll try to do this. So I've actually started working on this myself in the last week. Where's my next button? And that's just for one reason, so that I can show you a Go client and a Go server that do something fun and exciting. And we'll do that right now. Let's do that. All right, let's go over to Alt-Tab. Come to the pre-canned demo. The server's already running, so let's turn that off because that's just cheating. That's the wrong. Okay, that's going to be a challenge. Here. So you see up at the top here, which is hard to see, not really important, but I've got all my Docker Compose stuff happening up here. So you'll see when my server down here goes ahead and does something, it compiles the little Go application. You can see, oh, the log moved. So something happened, right? I'm not just cheating here. But my server has started. Now down here, you can see I was just making sure that it worked before. So let's go ahead and run the client. And so what this is doing is it's a purely application embedded zero trust example. If we had any interest to look at actual source code, we could look at that. But I also went through, this is the ZT Desktop Edge for Windows here. I have a Clint Compose identity, which I created earlier today. You can see, probably not, but that says ZT Edge controller on port 1280, which is a ZT Edge controller as a host's entry for my ZT Edge controller in here. And I actually added an intercept too, because like I said before, you don't have to just do application embedded, you can mix and match. And here's a mix and match where I actually have a website that I can now get at. It says, I wish I could make the address bar bigger. It says go.server.zt up. Oh, you know what? I can curl that, can't I? I can prove it that way. Let's do the curl. So now you can read that. 1 plus b is 100. And curl failed. Good demo. Let's go back to this one and put 100 in there. There we go, 101. What? Oh, yeah, that's interesting. So it looks like it worked. It just didn't give me the results. Maybe a minus v on that. Oh boy, minus v. Let's see what happens. All right, I don't see any results. Whatever. It worked over here. That's all that matters. So you can see it in the browser. You know what? I'll even make it bigger, and then I can choose just to make sure I'm not 1,000. We do it one more time. So that's going through the overlay network. If I turn off my server, which is this middle thing here, actually, let me turn off the ZT network. Right, shut that thing down. It takes a sweet second here for Docker to do his thing, but obviously this will no longer work. It'll start giving me timeout errors, and oh yeah, the server now is not able to work. Look at that, can't bind the session. I don't even need to show this because it's just gonna fail. All right, so I got a few more slides. I got a lot more slides, but I'm gonna just blow right through them. We have this OpenZiti test kitchen thing, which is where we make a whole bunch of interesting and fun uses of OpenZiti. Gotta love the chef hat, by the way, yeah. So we got a whole bunch. We have ZSSH. So SSH, why bother with ZSSH? SSH is a solved problem, right? You don't need to worry about that. Well, you put an open SSH server on the internet and see what happens. I think it's like 30 to 45 seconds it gets compromised. Well, with ZSSH, you got those no inbound firewalls. Everything's gravy, right? SCP works just like SCP. Fantastic, how amazing. All right, so there's that. Mattermost, I mentioned that earlier. GitHub and GitLab webhooks. If you're going to have a private chat app, you're gonna wanna know when every developer pushes, right? Of course I do. So here's Ken approving my Ziggy dabbing, right? You're gonna have Ziggy dabbing. So I got my pull request approved, fantastic. That comes through a GitHub action that uses a secret that is pushed and stored into GitHub as a secret and pulls it out and uses that, uses the SDK. Get a lot of SDKs. This one's one of my more favorites, so can't read that. So a Zetified JDBC driver, as I think it was, the fellow's name was Frank in this room last night, talking about how he hates getting on the internet, or getting on the VPN. I totally understand that because it's a pain. With JDBC, it's really neat. We've actually wrapped JDBC in a way, and we know how to poke it just right, and we provide a wrapper jar, which is usable in your SQL Studio of choice. In this case, it's whatever, I can't remember, DataGrip, that's what it's called, DataGrip. I never remember, from JetBrains. But we've also done it with another one, I can't come up with a name. It's not just for Oracle. Here you can see I'm using Oracle. Here you can see I'm passing that strong identity, which is a file on my file system in this case. I've called it Oracle with Ziti. But you can do it with Postgres, you can do it with anything. The way we did it was really great because you update your driver, you don't update the Zetified driver. You'll hear Zetified a lot. Got a nice little article about adding Spring Boot or Java or SDK, OpenZiti to Java via Spring Boot. kubectl, so boy, every Kubernetes, love it, right, everywhere. Kubernetes is a massive attack vector. If you leave your Kubernetes API open to the public, which lots of people do it by intentionally, some people do it unintentionally. That's not so great. So it's even better if you have Kubernetes, the control plane, the whole API, totally private. Oracle has a nice way to do this where they'll provide you a bastion, an SSH bastion that you can go through. Or you can just deploy a pod, and now you have access to your Kubernetes cluster using OpenZiti. And then you can get rid of the little dirty VPN client thing and go with Zetified kubectl, which of course, if you see any OpenZiti project, we'll just take a Z and slap it everywhere. So we'll call that kubectl, right? Because that's cute. Helms, right? Prometheus. So we've done all these things. Prometheus is really neat. You know, you've got that Kubernetes control plane out there. You've got Kubernetes wants to scrape, right? It wants to go out and touch your data and bring it back to Prometheus wants to go out and get your data and bring it back. Well, if you have a zero trust overlay network, how is that going to work? You got an ingress controller somewhere providing somebody or some Prometheus server access to your beautiful data. With Prometheus, you can either decide to deploy in a halfway method where you actually use a tunneling application inside of Kubernetes providing you ingress, or you can go the full application embedded zero trust way. I actually added our SDK to Prometheus and then deployed it. Why that was really cool was it comes with a config map reloader. When you change the config map, it tries to tell Prometheus to reload. That doesn't work when you have no open ports, even from intrapod, right? So container to container could not work there, which is really cool. Ansible, we've done some great work with Python and Ansible, Spiffy Spire. I showed you before, I didn't even talk about how the certificates I used were from Vault. I set the whole thing up for Vault, but I forgot to talk about that the Go example I showed you used certificates delivered from Vault, and I also forgot to show you that Vault works. My bad. Zetify uses the LD preload trick. Anybody ever hear of that? Yeah, no? So what that lets you do is it lets you put a library basically in front of the loading of all of your application. And so we're able to actually tap into the socket API that comes from, in this case, Linux, because it's the only place it's going to be supported. And that way you can add application embedded zero trust without recompiling an SDK into your application, which is super cool. Everybody's probably seen this, right? And if you haven't noticed, I've made it bigger. There's 11 times zero trust is mentioned in this White House document. There's also other stuff lately. I've got to update my slide, but I did update this one. There's a cool new website, zerotrust.cyber.gov. If you haven't gone there, that's where I got this stuff from, so you can take a look. And now you're saying, hey, so great. I got to put it in my shopping cart. I want to bring it home. How do I do that? Well, you can go out to OpenZiti.github.io. This is our doc page. It's not the best. I wrote the doc, but if you have any improvements for the doc, let me know. I'm happy to include them. We have 3 different layers. We have the full open source version, and then my company, will give you a free one, and you can buy it if you want to buy it. But I'm the open source shill, so I don't care if you buy it or not. Just use the open source stuff. Here's all of our socials. Twitter, OpenZiti, GitHub, OpenZiti. We have an OpenZiti.discourse group. If you go out there, you'll see I am active out there profusely. Ask a question, I'll answer it. We've got that test kitchen. We got OpenZiggy on Twitter too. Like I said, he likes to be kind of funny. You can get me at clint@openziti.org. And the big reason I do all this is for stars, right? Like a GitHub project is nothing if it doesn't have stars. I need stars. Who's got a GitHub account? Anybody? Go give me a star. Just one. I just need one, right? Make it worthwhile. So that's my presentation about OpenZiti and Zero Trust Overlay Networks. Any questions? So the question is, how do you monitor and get insights into who's coming in, et cetera? There are a preponderance of metrics. I think another presentation I saw, don't collect logs, collect metrics, right? So we collect all these metrics, and right now we don't push them to Prometheus, which is what I want to do, but we'll get there eventually. I want to use a Prometheus. So Ziti has a Prometheus export scrape target. Got to get that right. Prometheus has a scrape target built into it. We don't use it yet, but I'm hoping that NetFoundry, the company that deploys OpenZiti as a cloud, does that. The metrics are tied to your endpoint. So the pay-for product has a pretty dashboard and says, hey, Mahesh has accessed this service and has sent this much data, and here's what his profile looked like, right? And it tracks all of that for you. But you have to have a data lake somewhere that you can stuff all those metrics into. You have to have Kibana running. You have to have people who know how to write pretty reports and pretty dashboards. So that's why that's an enterprise type of feature. But it comes for free if you just want to go do that work yourself. So if you have people who do that or you know how to do that, then you can do that stuff too. Does that cover your question?
What about anomaly detection?
Anomaly detection. So OpenZiti is not in the observability space. So my favorite question that those astute among us ask me is, if you've got end-to-end encryption and you've got all this great OpenZiti overlay network stuff, well, what about my fancy firewall that I built that does all this great stuff for me? What about my WAF? How about all that sort of stuff? Those are great questions. Rife for one of you to use OpenZiti to make a new zero trust firewall or a WAF or something exciting with the zero trust SDKs. Right now, it's not an area that OpenZiti wants to solve. It's a huge area. I can say there are people who have built things on top of OpenZiti that are trying to do exactly that. Clint is accessing this at 2 a.m. and should not be, right? So that is the machine learning type of stuff that I've thought was interesting and I would like to play with, but we don't have a section of people doing that yet.
Okay, then my last question is you said devices and everything, but can you go all the way to kind of, IoT? Because one of the security problems is at the level of the IoT sensors, devices, etc.
So
Extend all the way there?
I'm going to say yes and no. Observing a sensor generally is not something that we operate at layer 3. right, or a higher. But reading a sensor is way down at level 0, level 1, whatever, right? It's way underneath us. So if anybody wanted to inject malicious data into the SCADA system, we're not going to know anything about that. But as far as an IoT device goes, for sure, we have a C SDK. Most of us all come from an IoT background, so we've spent lots of time in constrained devices. So we have a whole C SDK that does all that sort of stuff and is available to use on smaller devices. One of the guys who works for me is like relentless about, oh, don't use an int there, a byte will do. Yeah.
I have questions just about consumer applications and privacy. I think about private smart home, private consumer electronic things that you run on Raspberry Pi or some
Yep.
other embedded device. And could OpenZiti be useful in, not messing with your home firewall?
Absolutely. Yeah, in fact, let's see, come on, internet. Yes.
Recommended way to be the remote client side?
So what a great question. That opens a few doors. First is, right now, currently, you will need some sort of agent in order to get onto the overlay network, or you will need a purpose-built application that has zero trust baked into it. We have this new thing called browser, looks like this, which its job in life is actually injecting that zero trust SDK into your browser dynamically so that you would be able to access zero trust resources without having an agent installed, agentless installation. It is alpha as alpha gets. So if you want to try it out, we're taking subscriptions. People can come right up and try it out. Well, not here, I'm not the browser guy. Kurt's the browser guy, but he does want people to try it out. I can use it right now to access that Mattermost instance that I had showed you before.
Say browser, it can be like Firefox.
Yes, so basically we deliver the JavaScript SDK from a trusted HTTP agent. This is, we're gonna get really complicated here. And then what happens is that SDK is bootstrapped in your browser, and then now you gotta do a OIDC, what's the dance where you go to Google and you get the unified login. I don't know, whatever it's called, right? So you gotta go and you gotta log into some third party. And that third party will provide you a bearer token, a JWT, a JOT, however you wanna say it. You then present that JWT back to the controller, and the controller goes, yes, you can come in now. Here is your identity, here's your session. Now the JavaScript SDK can connect to those edge routers and make those secure connections. Now, that's really complicated. We do have this fellow out here, Jeff, also works on my team. He'll show you how to set up Minecraft. I know everybody here probably is gonna just go home and do that right now. But also, there is another one where he does Home Assistant, which is a great, I don't know, here it is. I created a zero trust overlay network to access my Home Assistant. Great little picture of him right there because he had left his Home Assistant open to the world and noticed the camera was moving. And at that point, he's like, so he turned everything off and got all paranoid, right? Because somebody had hacked into his Home Assistant. And so that's why he took this picture, because it looks like somebody's looking at him. But yes, it's really useful for all those things. Now, one more thing I'll say. Those are all browser-based apps. When I talk to people about where I see SDKs and OpenZiti fitting in like bread and butter, I don't know if you like butter on your bread, but I do, is a mobile app. If you make a mobile app, you almost certainly have a developer on staff. Almost certainly. And like my favorite example is Facebook, right? Like everybody thinks, oh, I'm using Facebook on my phone, it has to be public. It does not have to be public. When you log into Facebook, you could get an identity delivered to your phone, which is now in your phone, depending on how Facebook or whatever the app is that deploys it. You could have that identity stuffed into your application and use that from your phone and have two different facades, the internet facade and the actually secure facade from your phone or whatever. So if you make an app, it just is easy because you just take the Java SDK or the Kotlin SDK or the Swift SDK and you stuff it in your app. Yeah, so who runs the overlay network? It's up to you. If I go back, let me go back that. You have three choices. You can run your own overlay network if you so desire. That is the open source stuff right here. If you are an app developer and you don't care about the overlay network, you can sign up for Zeds, the ZD Edge Developer Sandbox. It's just a sandbox, though, so it's not like a production thing. Or if you have fewer than 10 endpoints, you can use Cloud ZD Teams. And if you have more than 10 endpoints and you want to spend some nominal price, you can pay my employer and we'll host it for you. How magnanimous, for just a small, small fee. Any other questions? All right, thanks everybody.